so on 1, 0, 0, 0, 0 here, 0, 0. Like this. We compare the two. Compare the two. Now, this is again column. This is row 1, column 1, right? Row 1, column 1. So we have the following. It's equivalent to very similar. So we have row 1, column 1. So we have x1 here multiply with x1, x1, x2, and so on. x1, xn. Yeah, now this is row 1. Now row 2. x2, x1, addition. Yeah. x2, x2, addition. x2 multiply xn, addition. Go down, I have xn, x1, addition. xm, x2, so on, xm, xn, addition. And this matrix equal to 1, 1, so on, 1, 0, 0, 0, 0, 0, 0, here. Like this. Okay, and then you compare. Right, you compare, then you compare, you can find out, right? From here, you can find out that column I, row I, multiply with row J is equal to delta Ij. This means that if you have 1, 1, then it should be number 1. 2, 2, it should be number 1. M, it should be number 1. But otherwise, then it's always 0. So the proof is very similar between the row and the column 1. Now, property 4. Property 4. This is property 3, property 4. Property 4. Or unitary transformation. A unitary transformation. A unitary transformation never change. Never change the Euclidean norm of the vector. Euclidean norm of vectors. Of vectors. What does it mean? It means that you take the Euclidean norm x multiplied with a vector A, then you should have is equal to the norm of the vector A. Like this. Okay, the proof of this one. The proof of this one. Now, if we take the norm, x multiplied with a vector A, and the norm square. If we take the norm, take square, then we know that the norm equal to the xa. You take the Hermitian multiply with xa. Right? We know that the norm square equal to the inner product. Right? The norm of a vector square equal to the inner product of that vector multiplied with the vector itself. So we have this one. But as you see, Hermitian of a product equal to the product of the two Hermitian. Swap the order. So this one equal to this one equal to the A Hermitian. A Hermitian. Multiply with the Hermitian transpose X, and here you got X multiply with A, like this. Yeah, and then you see because this is unitary matrix, we are working with unitary matrix. This means that X is a unitary matrix. Then you have the A Hermitian multiply with I multiply with A, and it's equal to A Hermitian transpose multiply with A, and then it's equal to the norm of A squared. And then we finish the proof. It means that if you have X here, unitary matrix, you multiply with a vector A, then the new vector XA has the same Euclidean norm. Okay, that's a property 4 of unitary matrix. Is it okay, everyone? Now, next we go to positive definiteness. Positive definiteness. Next we go to Hermitians. Hermitian matrices, positive definiteness. Negative definiteness.